Okay, so what is either the or your alimentary canal? So when we're talking about that canal, what does it have to do with digestion? Let me say that. Is it all primary organs, all secondary, or is it a mixture of the two? It's certainly all primary, and then you have secondary organs that add to it. So I suppose you could say it's kind of both. So give me an example of a secondary organ. Pancreas is one. Okay, liver, spleen a little bit, and then finally gallbladder are all accessory organs. So what's a primary one? Stomach, you could say esophagus, intestines, small and large. Yes, that's right. Okay, so as far as breaking down proteins, is there only one enzyme that does all proteins, do you think? There's one important one, yes, but there's not just only one that does it. One is called pepsin, that's the major one. What might the other one be? It was one of your vocab terms. It comes from trypsinogen. Entero something. Enterokinase is also an enzyme that breaks down molecules as well. And it's kind of like pepsin is an exception because you really don't picture that being an enzyme. Why might that be as opposed to your enterokinase and amylase? Yeah, it doesn't end with the suffix ase. Right. So your pancreas, as you can see, does many different aspects. Will split triglyceride molecules into fatty acids. Is this the only organ/gland that does this for our digestive tract? Is the pancreas the only one? No, it is not. What else might break down materials for us? Your liver makes it, but it doesn't store it. Yeah, the gallbladder actually stores it. Okay, so moving forward, okay? I said trypsinogen, didn't I? I meant to say trypsin. Okay. So keep it. A lot of times there's just no one single enzyme that can do that. And I think that's, I would say, whether you want to think of an advantage or maybe it's just the way that we are wired or so by the man upstairs, that's certainly an advantage. Okay, now my mic went cold. Now it's hot again. So, as far as the animal kingdom is concerned, why do you, well, if throughout the course of the year, uh, whether it's a brown bear, grizzly bear, they'll eat shoots and roots and berries and fish, deer, whatever they can get their hands on. So that makes them, you could say, a generalist. In other words, they grab what is accessible to them. Different types of animals are specialists. Okay? So what might be a problem as far as food gathering is concerned if you are a specialist? If your prey item crashes, what happens to your food source? It crashes as well. Okay? So that could certainly be a problem. So in a similar fashion, as far as breaking down these proteins, Yes, pepsin does a very good job, but not all enzymes can break down all different types of proteins. So having this would be, again, whether you say want to say it's an evolutionary advantage, just the way the man upstairs designed us. Either way, okay? So this kind of works in a similar fashion. Trypsin and enterokinase. What do we mean by works in a similar fashion, you think? Because how does the pepsin mechanism work? It works in your stomach, but you have to talk about different types of secretions, and you got to talk about acid. The acid does what to pepsinogen? Does it deactivate it or activate it? It activates it to pepsin. So that's what we mean. It works very similar to the pepsin mechanism in the stomach. Okay. So for those of you just coming back because of meeting with Jostins, we really haven't talked about a whole lot. Did we start on this one? Yeah, we started on this one, but I think that's where we left off. And then we just started talking about this before you came back. Okay. I'm going to see where we're at with our schedule here. Okay, I see won't really start the liver until tomorrow, but I want to do just one, or where does that put us? Gesundheit. Yeah, we'll just do that first one. Okay, does everyone have this information that wants it? Okay. Okay, now, one of the things, this is very important, while not only just in this chapter, but also when we talk about the endocrine system as well. Because your endocrine system also works in this function to help raise and lower blood sugar levels. Okay? We don't spend a whole lot of time on this, more so when we discuss the endocrine system, because it is such a vital portion. Because if someone is perhaps hypoglycemic, just take a guess. We have never been introduced to that term, but someone is hypoglycemic, just take a guess. Their blood sugar levels too high or too low? So think of this. If you go across the hall to the preschool, some of them are just jumping and bouncing and screaming and said, oh my gosh, they are so what? Hyper. So what does that mean with their energy levels? Too high or too low? Certainly very high. Okay? So with the same type of logic, if someone is hyperglycemic, that means their blood sugar levels are too high. If they are hypoglycemic, well then that means their blood sugar levels are too low. Okay? So when this happens, okay, we talk about this a little more, when we talk about the endocrine system, because it's a type of feedback mechanism. Here, we're just saying what it does. The next time you see this, we want you to be able to explain why it does that. Okay. Just picture something like if someone was to just eat celery all the time. Celery. Not only would it be blah, you would die. Why is that? It actually takes more energy to digest that than what you actually take in. So in the same type of logic, what we see happening here, glycogen is a very large starch, just like cellulose. Cellulose is what you find in plants. It's a very large carbohydrate. It takes a lot of energy to break down that starch or that cellulose. That's why you say it takes more energy to do that. So in biochemistry terms, a whole bunch of glucose molecules linked together makes glycogen. And again, the way we're just designed by the man upstairs, if our blood sugar levels are too low or hypoglycemic, your liver will start breaking this glycogen molecule down into individual glucose molecules. So if this is a really long chain and you start breaking that up into its individual links, your blood sugar level is going to start to come back up to a normal range. So just the opposite would occur if your blood sugar level is too high, just like we said, oh my gosh, they are so hyper across the hall. Well, then what's going to happen is the insulin then is going to cause one of two things. Either your cells are going to start to take in those sugar molecules to bring those levels back down to a normal range, or it's going to take all those individual units and start linking them together in a chain to form glycogen. So it works in both directions. Okay, so that's where I think we will stop for today. I've got this paper for you. You can work on it, don't work on it. You've got plenty of time to do so. We see we got a vocab quiz 3 on Friday. And these papers, I have wrote down at the 11th. We'll see once where we're at on Thursday. Otherwise, we'll catch up to you next time.